Moving on to the Adept level. Rational exponents. We're just going to combine our knowledge of fractional exponents with exponents that are now negative. So I'm going to rewrite 8 as a power. Remember, 8 is 2 cubed. But now I can multiply these exponents together. So 3 times negative 4 over 3, the 3's cancel. So I get 2 to the negative 4. Okay. Well, now I can work with the negative exponent like so. This becomes 1 over 2 to the power of 4, which is a 16th. So 8 to the power of negative 4/3 is 1/16. Next, 36 to the power of negative 3/2. Well, that negative 3/2 can sit there. But 36, that's a perfect square. That's 6 squared. So I can multiply those exponents now. So 2 times negative 3 over 2, 2's cancel. So I get 6 to the minus 3, which is 1 over 6 to the positive 3, which is 1 over 216. Next, hundred is 10 squared. Multiply these exponents together. 2's cancel. So this is 1 over 100,000. Simplify and compute numerical values where possible. So here I have 144x to the power of negative 1/2, and then everything is being raised to the negative 1/2 again. So the one on the inside is only affecting the x. It has no effect on this 144. But this exponent here, being outside the brackets, affects everything. So I'm going to apply this outside exponent to everything on the inside. So that's going to give me 144 to the power of negative 1/2 times, and this is x to the minus 1/2 still, but that is then being raised to the negative 1/2. Okay. So I have a number being raised to a fraction. Yuck. Well, 144 is 12 squared. Okay. And over here, okay, I can't do anything with x. That's just a variable. But these, I can multiply them together. So negative 1/2 times negative 1/2, that becomes positive 1/4. Okay. I can multiply these now. So 2 times negative 1 over 2, the 2's cancel, so I get 12 to the negative 1 times x to the 1/4. Okay. And of course I can write this as x to the 1/4 over 12 to the 1, or just 12. All right, x to the minus 2 to the power of 0.3, and there's a little hash mark above the 3. Hopefully you remember what that mark means. It means 0.3 repeating. So it's 0.33333, and it goes on forever. Okay, well, that can be written as a fraction. Okay, repeating decimals, okay, they always come back to the number 9 in some way. And of course 3 over 9 is reducible. That's a third. Okay, so 1/3 as a decimal is 0.3 repeating. So I'm just going to rephrase the question. like so. And there we go. So really all I can do is multiply the exponents. So negative 2 times 1/3 is negative 2/3. And then I'll write that as 1 over x to the positive 2/3. Okay, a common mistake that I see is kids will take this repeating decimal and they'll just pretend that that little sign is not there. And they'll assume this. Please don't do that. All right, because this, I've shown you, is 3/9. Well, if this is true, remember 0.3, that's 3/10. Okay, so if these are the same, that means that 3 over 9 is the same as 3 over 10. That is absolutely false. Okay, so this is completely false. The next one, right off the bat, I can see two different ways of looking at it. We have multiplication of two powers inside the brackets, and then everything is being raised to the power of 4/3. Well, I can actually work on the inside first if I want to. So when you multiply powers of equal base, you just add the exponents. So when you add negative 1/2, that's the same as just subtracting 1/2. And that's still being raised to the 4/3. I haven't dealt with that yet. Okay. What is 2 minus 1/2? Well, 2 minus 1/2 is 1.5, or that can be written as 3/2. And that's still being raised to the 4/3. But now I can multiply these guys. So 3/2 times 4/3. Well, I can see the 3's are going to cancel, and 4/2 reduces to 2. So my answer is actually just x squared. Again, if you can't see how I went from this to this, I'll just show you the fraction. 3/2 times 4/3 equals. So those cancel. But 4/2 is the same as 2/1. So that's just 2/1, which is 2. So that's how I got this exponent here. Evaluate 8 to the power of negative 2/3 using two different methods. So here's one way. I can write 8 as a perfect cube, and that's still raised to the negative 2/3. Okay, so, and these, of course, I can multiply. 3's are going to cancel, so I get 2 to the negative 2, which is 1/2 to the positive 2, so it's a quarter. Okay, well, how else could I have done this? Well, what I did here is I effectively dealt with the fractional exponent first. What I could have done is dealt with the fact that it's negative and then dealt with the fraction. Here's what I mean. I can write this as 1/8 to the positive 2/3 right now. And then I can just stay in the denominator. Don't forget, the 1 is still there. Now I can do 8 is 2 cubed. So I multiply these. So that gives me 1/2 squared. So I still get 1/4. So sometimes you might want to deal with the negative exponents first and make them positive. Maybe it looks easier. Or you want to deal with the fractional exponents. It's really up to you. But there's two different ways of getting the same answer.